Hi there. We will learn in this video how the process to compare between engineering alternatives from the economics point of view. So the process here has six steps. The first one is to define the investment alternatives. It might seem like simple, I just buy this equipment or this equipment, but you have to establish a list of alternatives that are feasible, mutually exclusive, and collectively exhaustive. So what does this mean? First, feasible, you have constraints, you have to comply with these constraints. Every one of these alternatives is feasible by respecting the constraints. Mutually exclusive means it's either or, but not both, meaning that if I have an option to buy an equipment and I have an option of buying another version of it, so with different features, and I have a third, I might have a third option with combining the features of both. I need to represent that as a separate alternative. So I don't like say alternative one, alternative two, and kind of say, all right, I will figure out the combination of both by doing the analysis or comparison of both, without really exclusively kind of represent the combination of both as an alternative. That's not correct. You have to consider all possible alternatives, not considering combining them after the analysis. You have to combine them before the analysis and create new alternatives to compare. And then collectively exhaustive, so no other alternative is available within the capacity and time availability you have. And always remember there's one alternative, which is do nothing. So if you have a current situation, a traffic intersection, and you're thinking about implementing a new traffic signal technology, so you always have the alternative, just keep it the same, right? So that's one alternative. So after you define the alternatives, you have to define the planning horizon, because some alternatives can have different lifespans. So equipment manufactured in one country can have like lifespan different quality than another country. So we call here useful life, or the life where this equipment will be economical to maintain and own. So in one thing we will do here is we'll assume that equipments can be purchased over and over again or can be renewed. And for the sake of being fair, if I'm comparing between this alternative of 10 years and the other one of 15 years, it's not a fair comparison. It's not apple to apple comparison. So what happens is I can use the shortest life, meaning that I can cut at 10. So the equipment with 15 years, I'll just consider only the 10 years, the first one of them. It's might not fair because you will exclude the big picture in this case. Longest life, the third method here, is also not fair because you assume that you will buy one equipment, the first one and live with you for 10 years, and then buy it again, but just make it live for 4 years. It's not really fair. So the fairest one, in my opinion, is the least common multiple. So if alternative A here in this case has 3 years and the second one B has 5 years, the least common multiple is 15. So the first equipment I will buy it once, twice, third, fourth, and fifth. So 5 times. And the second alternative will be renewed 3 times, or done 1 time and then renewed 2 times after that. So now I have the same planning horizon, and I can compare between the two equipment, or the two alternatives. Now once you define the planning horizon, you need to develop the cash flow diagram. So 2 and 3 can go parallel at the same time, and you can do 3 first, develop the cash flow, and then define the planning horizon. But defining the planning horizon in this course here, I give you the planning horizon, I give you the cash flow, I give you the values of everything in the cash flow. But in real life, you have to do estimation of whatever goes in that cash flow. So you need to figure out how much you need to invest, how much you will buy this equipment, how much it will cost you in maintenance. So different methods of doing that: life cycle and cost estimating, and controlling and accounting of cost. So we're not doing that in this course. That's not, we're assuming that's given to us. The next would be specifying the time value of money. So we discussed and explained the meaning of time value of money, but how we really find the value for the time value of money and how we set it up. We used to call it I, but it's really the minimum attractive rate of return. This is really the meaning of time value of money. And it's not simple to figure out MARR because it represents different ways of securing the capital you're using in this project. So MARR should be greater than the cost of securing this capital. So the cost of a capital, meaning that how much it will cost you to bring a $1 million to use for this project, and you have to return this $1 million back to the origin of that. So if there is an investor with you, they expect to get return. And if you're getting it from a bank, they will get their interest back, right? So these are the two main types of capital. The first one is debt. And debt, you can get that through loans or bonds, and we'll see these in future lessons. Or you can get equity. So people will invest with you. They're not giving you a loan. They're giving you their own money to invest. And these can be like in the form of stocks, or another version of stocks is like retained earnings. So the stakeholders or stockholders will keep their earnings instead of taking them. So they kind of buying more equity in your company. So that's more on the financial side, but we're dealing with economics. So that's the link between financial and economic kind of life. You need to figure out what's MARR, and that depends on the financial aspect of the project, where you're actually getting the money. Excuse me. So the next, after you have all of that information, is you compare. You compare between the alternatives, and you have to be fair also in comparing between them and calculating based on quantitative measure. And this quantitative measure will be a single value that represents every alternative with this whole different cash flows that happen at different times. So we're calculating the worth of every investment or every alternative, and that worth will be equivalent of this whole cash flow. So kind of squeezing that cash flow in one value and representing it with this value. But now this value, if I compare between alternatives, the worth of every cash flow of every alternative should be calculated at the same format or at the same point. So it has to be either present worth, so I'm using present worth to calculate all my alternatives or compare between them, future worth, or instead of just one point, I'm kind of melting that value over and spreading it over a period of time, so annual worth or uniform series worth. There is also another way to compare between alternatives, which is not using the worth approach. We're using the internal rate of return approach. So that's something we will cover in a different video. But typically, when you compare between alternatives by comparing their worth values, these values have to be like the same format, apple to apple, not like comparing present worth to future worth of two alternatives. So in the next video, we'll see the application of present worth and future worth on annual worth, and also the implementation of internal rate of return. Thanks for watching and take care.